What's up, YouTube? So this is the part 2 of our lecture video about the how to draw a Lewis structure. So we can see meron tayong mga mga practice exercises that I made na merong mahirap, meron ding hindi. Pero let's face it, ang binibigyan ng mga problems sa quizzes ng mga instructors and professors natin ay sobrang hihirap. But in this lecture video, I'll provide you some of the compounds. Okay, huwag na nating patagalin pa. Simulan na natin. Okay, let's use this whiteboard, Microsoft Whiteboard for our lecture video. Okay, so tayo nasa slide 15. Okay, para meron tayong idea of what group of the elements it is paste din natin yung ating periodic table para malaman natin yung group number of each the atoms. Okay? Okay, to start with, number 1, simulan natin sa may phosphorus trifluoride. Actually, ito is similar dun sa may phosphorus trichloride natin nasa problem in part 1. So, we're in the central atoms is the P, central atoms the P, and the terminal atoms are the F. So, I just want to emphasize that these are the keywords that you need to take note whenever you're drawing a Lewis structure. So, these are the Lewis symbol of the atom. So, it is actually covalent bonding. And next is the central atom. Identify the central atom. The terminal atoms bonded to the central atom, and does it obeying octet rule? Okay, the 8 electron rule. Pero syempre, there are always exceptions to this rule. So, ayan, makikita natin yan sa ating succeeding problems. Okay, let's start. Okay, for the phosphorus trifluoride, the structure niyan, of course, phosphorus is group 5. It has 5 Lewis dots, and fluorine is group 7. So, 7 Lewis dot, tatlo yan. Magkipag-bond yung tatlo dun sa may central atom natin. May matitirang dalawang or lone pair. Ayan. So, lone pair ang tawag natin dyan sa electrons na yan. So, may matitirang dalawang electrons here bonded to fluorine. Ayan, ayan, ayan. And then, don't forget to write the remaining Lewis dot for the fluorine. Okay. Ayan, so, ilan ba yung natira? Diba, 6? Kasi 1, 2, 3, 4, 5, 6. Kasi naipag-bond yung each of the fluorine atom sa may phosphorus natin. Now, the question here is, guys, are they all obeying octet rule? Yes, nag-obey silang octet rule kasi, diba, sa bonds natin, it is counted as 2 electron to that corresponding atom. And this dot is 1 electron count. So, ang bibilangin natin yung phosphorus natin, ay 2, 4, 6, 7, 8. So, 8 electrons, ito base octet rule. And for our fluorine, ayan, 1, 2, 3, 4, 5, 6, 7, 8. Kasi 2 electrons nga. So, octet rule. Ayan. So, keep in mind, Lewis symbol, central atom, terminal atoms, and octet rule. Okay? So, we're done with number 1. Ayan. And next natin is the number 2, which is the beryllium. Beryllium chloride, I shall say. Ayan. So, number 2 natin is, meron tayong, what are the atoms? Beryllium. Anong group niya? Group 2. So, 2 Lewis dot. What about chlorine? Meron tayong dalawang chlorine. Group number sa periodic table, 7. So, 7 Lewis dot. Ayan. So, ang central atom natin, automatically, is the beryllium. Kasi siya yung nag-iisa eh. So, tatandaan nyo yan, central atom is often, siya yung nag-iisa sa ating molecule natin. So, beryllium, since 2 chlorine, okay, intuitively, so makikipag-bond yung ating chlorine dun sa beryllium natin, yielding this Lewis structure of a beryllium chloride. Okay, as you can see here, ayan, makikita natin that the beryllium does not obey an octet rule kasi nga, as I discussed on the part 1 of my lecture video, that there are exceptions to the octet rule, such as the odd number of electrons, the less than valence octet, and the more than valence octet. And kung mapapansin natin that beryllium is in group 2, so therefore it is impossible for it to form an octet bonding valence electrons. Ayan. So, that's for the beryllium. Ayan, the Lewis structure for that. Now, ang mangyayari ngayon, for number 3, is the thionyl chloride or SOCl2. Okay. First and foremost, syempre, ang sulat natin, yung mga molecule, mga atoms involved. So, S. So, it has what group? Group 6. So, 6. Oxygen. Ayan. So, 6 yan. And then, chlorine, dalawa. Mangyayari dito, ano ang central atom natin? Of course, hindi pwede si sulfur, ay si oxygen. At kasi, bakit? Kasi usually, ang oxygen natin ay terminal atoms. And sulfur natin is the best candidate. At kung isi-search ito sa internet, sulfur is the central atom of the thionyl chloride. Okay? So, this one is the central atom and this one is the terminal atom. So, often, ang oxygen natin ay terminal atoms natin because this one contains d orbital. So, sulat natin. So, the S is bonded to oxygen. And then the two chlorines is bonded to sulfur. Ayan. So, there are may possible structure for this SOCl2 na mag-experimentan ninyo na i-drawing. Pero this is the correct one. So, how many, question here is, how many remaining dots for our central atom na ipag-bond siya sa 3? So, there are 3 remaining electrons here. For the chlorine, ay pag-bond sa isa, yan. So, it has 6. 6 natin. So, 6. And then, for the oxygen, pag-bond sa isa, may matitirang 5. Yan. Usually, pagka ganito, hindi siya stable. At tatandaan ninyo na pagka nagdodrawing ka ng Lewis dot, dapat meron kayong laging lone pair para mas stable. I-discuss ko rin yan sa valence shell electron pair repulsion theory on the next video. So, in the case of this, so mapapansin natin, hindi rin siya nag-obey ng octet. So, this one is 2, 4, 6, and then 9 electrons. So, expanded octet yung sulfur natin. So, isa siya sa mga exceptions to the rule because it contains a d orbitals. And for oxygen natin is 2, 3, 4, 5, 6, 7. So, ang oxygen natin ay hindi nag-obey ng octet rule. So, ano kaya pwedeng gawin natin dito? So, sa last lecture, it is possible to form a multiple bonding. So, magdadagdag tayo ng isang bond here. Magbabond yung dalawang electrons doon to form this compound. So, makikita natin ngayon, ito na ngayon ay 8 electrons. And this one is 10 electrons na. So, expanded octet. Tandaan nyo, dapat even number yung ating number of electrons in the atoms. But there are always exceptions to that, pero mas komplikado na yun, okay? So, we're done with number 3. Now, let's dive in to number 4, which is the ammonium ion. Ayan, ammonium ion. So, what are the atoms involved again? Okay, Lewis symbol. Lewis symbol, we have N, which is group 5. So, 5 Lewis dot. And then, hydrogen, 4 na hydrogen. So, 1 Lewis dot kasi ay group 1. So, meron tayong positive charge dito in the ammonium. So, diba, ang ruling natin is kapag meron positive charge, magbabawas tayo ng isang dot or isang electron. However, is it on the nitrogen or dun sa may hydrogen? Ang sagot dito is, kapag sa hydrogen tayo nagbawas, mawawalan na ng electrons yung hydrogen natin. So, ang mawawalan ng electrons automatically is our nitrogen, correct? So, it can form a 4 bonds with the hydrogen natin, forming this compound. Ayan, this compound. So, this is the structure of ammonium ion. Some books, ayan, so don't forget the positive charge. Meron ding ibang books or na much preferable na sinusulat ang ammonium ion natin as ganito. Ayan. Ayan. So, that is for our number 4. Ayan. So, let's put a check on this. Now, dito naman tayo sa may xenon tetrafluoride. Xenon tetrafluoride is if you would notice that it is a noble gases. However, bakit kaya gano'n? Akala ko ba that the noble gases are stable itself, they are not dependent, and hindi na kailangan ipag-bond? Ang sagot kasi sa question na yan is that the xenon, if you study the periodic tables na malaki yung atomic radius niya, so sobrang dami na, sobrang laki, at sobrang layo na ng valence electron niya dun sa may nucleus. So hindi na niya na-attract, wala nang electrostatic action doon or minimal. So the valence electron tends to form bond with the halogens into it. So by writing, of course, the xenon is in group 8, the Lewis dot. Okay, 4. And then the fluorine is in group 7. So it has 4. Ayan. Automatically naman, ang fluorine natin is the central atom na naka-bond doon sa ating structure. Ayan. So I'm just gonna put this first kasi medyo nawala siya. Ayan. Ayan. This is the things that we need to keep in mind when drawing ayan. So maayos na. Sorry for that. And then upon drawing this, we notice that the 4 fluorines will occupy remaining 4 electron pairs. Ayan. XeF4. Ayan. XeF4, the terminal atoms. And then don't forget to write the Lewis dot. Lewis dot. Ayan. Lewis dot. And then lone pairs. Ayan. So that's it. Diba? We don't need to count kasi valence. It is obeying octet rule yung mga fluorines natin. Except for the xenon, so meron siyang d orbitals, kaya expanded octet din yan, wherein it contains 12 electrons, just like in the sulfur. Okay, so it is finished. Then let's dive in to number 6. Of course, sobrang dali naman ito. It's HBr. Okay, hindi ko na siguro isusulat yung nito, yung Lewis symbol. Ang gagawin mo lang is to bond the H to the bromine. Ayan. So, bromine is group 7. So, babawasan mo ng isang dot, forming this. So, that's number 6. That's it. The same cases with antimony pentafluoride. The same case with xenon. So, it is group 5. So, it has 5 fluorine atoms. Kaya walang matitirang Lewis dot sa kanya. So, i-write ko lang din siya as is. Ayan. Para mapadali ang discussion natin. Ayan. So, nagmamatter ba yung shape ng mga Lewis structure natin? The answer is yes. Kasi if you consider the valence shell electron pair repulsion theory, but we are going to discuss it on the next video. So, kino-consider ang mga shape na yan. Hindi kayo pwedeng kunwari mag-drawing na antimony. Nandito yung 5 bonds. No. That is not the case for that. You need to draw it properly. We have rules to follow. Okay? So, in the case of HCN, ayan. So, delete natin to. For number 8 naman. Number 8 is, i-drawing ko na lang din siya as is. But, in the case of this one, the HCN, C, is directly bonded to the N. Diba? Kasi, you will have an idea what is the bonding pattern for this molecule by looking at the written chemical formula. Okay. So, mapapansin natin dito that the carbon is group 4. So, naipag-bond siya dito sa nitrogen natin. May matitira siyang dalawang Lewis dot. Group 5 natin is yung ating nitrogen. So, may matitira siyang 4 Lewis dot. However, we would notice that it has only 2, 4, 6 electron. Does not obey octet rule. The same with the case of nitrogen. 6 oxygen. Ayan. So, we need still 4 electrons for both of each. Ano kaya ang pwede natin gawin para ma-meet yan? So, the answer is, pag bonded mo sila, di ba? Multiple bonds is possible for this. To remove this one, ayan, mawawala na to. mawawala na to. If you count the total electrons, 2, 4, 6, 8, nag-obey na siya ng octet rule. Ayan, ito rin. So, ang number one tip ko sa inyo when you are writing a Lewis structure, magtingin kayo ng mga structure na available sa internet so that you can draw the Lewis structure of a molecule intuitively. So, by instinct na lang minsan ang pagdodrawing ninyo. You have to master this. Kasi this is one of the basic concepts in chemistry, okay? For number 9, it is the sulfuric, it's not sulfuric acid, but it's hydrogen sulfide na lang. Tatawagin ko siya. So, for this case, we have H, S, and O. Ayan. So, as we discussed on the SOCl2, the central atom is often the sulfur because the oxygen is often a terminal atoms. And if you look at the organic compounds or the concept of hydrogen bonding or hydroxyl group, the often bonding pattern of the OH group is this one. Ayan, meron tayong nag-a-appear na ganyan. So, let's try formula, di ba? So, sulfur has 6. Ayan. Oxygen has 6. So, mag-experiment tayo ng ating bonding patterns, di ba? So, can draw this as hydrogen. Ayan. So, may apat. Tapos, yung tatlong oxygen, ganyan. But that is not the proper way of doing it. Tapos, may isang Lewis bond dyan. Kasi, hindi siya magkakaroon ng octet rule. So, what we are going to do? Tandaan ninyo that when you see madalas, often, when you see an O and H, the O is bonded to the H. So, therefore, our structure for this is meron tayong S, O, and then bonded siya sa H. Ayan. Just gonna erase this to clutter here. And then, another one. Okay. O and H. And then we have still O. Ayan, di ba? Kasi we only have 2 hydrogens for this. Then after this, ang mangyayari, our hydrogen, so it's group 6 dito. So for Lewis na matitirasin ay pag-bond siya sa meron siyang dalawang bonding. The same also cases for this one. Ayan, to obey octet rule, di ba? Pero in our sulfur, meron pa tayong naiisang bond dito. And for oxygen, it has 5. So intuitively, di ba? Pagbabond din natin itong dalawang electrons na to form a double bond, right? After forming a double bond, ayan. So all of the oxygen are obeying octet rule X. Ayan. So after this, so meron pa palang dalawang sulfur lone pairs for the sulfur atoms for that. Yan. So this is the proper structure of the H2SO3. Always remember this that the O is often bonded to H. Ayun. So for our last number, the SO4, 2 negative, which is an ion, di ba? Meron tayong negatively charged. Ang cases dito is, meron tayong S, yan, which is a group 6, 6 Lewis dot. Meron din tayong oxygen, which is group 6, 6 Lewis dot. Ayan, it has 4. Pero meron tayong negatively charged. The concept of this is, meron din kasi tayong concept ng resonance structure, but we will not go into that. But the common rule is that if you take a look at the periodic table, oxygen is more electronegative than sulfur. So, ang negative charge ay mapupunta dun sa may dalawang oxygen natin. So, you need to know. For example, okay. For example, you have a O2 negative. Although meron naman talagang ganitong ions, but it is a stable ion itself kasi nga it contains 8 bonds. Therefore, it is not capable of bonding with the sulfur. Kaya, ang mangyayari dyan, guys, is we have 2 oxygens that contains a negative charge, madadagdag na electrons. So, in the case of this, sa Lewis dot natin, meron tayong dalawang neutral oxygen and meron tayong dalawang negatively charged oxygen na contains a 1 Lewis dot. Ayan, kasi oxygen siya. So, yung sulfur natin, it has an expanded octet, of course, and you have to obey the octet rule. So, ipag-bond natin yung 4 na oxygen around the sulfur atom. Ayan. So, may natitira pang dalawang electrons here. Dito, so in order for us to valence yung octet role natin, magkakaroon siya ng double bonding to 2 oxygens. So, pili na lang tayo ng kahit isa dito. For example, let's say on this one and this one. So, nagkaroon na siya ng ayan, octet rule. Tandaan niyo guys that the multiple bonding is possible basta ma-obtain niyo yung octet rule. And then this one is negatively charged. Okay? So, ilan ba ang natin nagband dito? Di ba isa lang? So, mariretain niya yung 6. Ayan. To form an octet. Ayan, di ba? So, bibilangin niya 2, 3, 4, 5, 6, 7, 8. Ayan. So, meron din tayong concept of resonance structure but that is not the scope of our discussion. Perhaps I will discuss it on another video. Ayan. For another representation of the sulfur, ayan. So, sulfate pala, I mean. Ayan, ganito ang itsura niya. And then, ayan. 2 negative. 1, 2, 3, 4. Oops, sorry for that. Ayan, that is the Lewis structure. So, that's all for the basics of how to draw a Lewis structure. Pero I suggest na you could search the internet na para ma-familiarize kayo sa mga different bonding patterns natin. Kasi remember, this is a basic concept of chemistry and you have to master this. Kapag di nyo na-master ito, medyo magkakaproblema kayo in the succeeding topics of the chemistry, okay? So, thank you so much for listening and I hope you learned something in this video. If you have any questions, you can comment below and I will try to address it, okay? So, thank you so much and see you on our next lecture video.